Let us discuss about the three concepts: domain of definition, limit, and continuity of functions of two or more variables. I have written three types of functions. The first two are involving two independent variables x and y, and the third one is involving three independent variables x, y, z. We may define in this way a function of n variables also, where we define the n dimensional space with the n tuple point having coordinate x1, x2, dot 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 xn. This is a generalization of this concept. First of all, we would like to understand the concept of two or three variables in the domain of definition as well as limit and continuity. Just see that in this case, the domain of definition is the punctured plane y not equal to x, because whenever y is equal to x, we have fxy undefined. So the domain of definition is the punctured two-dimensional plane where we just discard this line y equal to x. This y equal to x line is punctured from this two-dimensional plane, and that is the domain of definition. May be written as R2 minus y equal to x. That means we discard all the points where the values of x and y are equal. This is termed as punctured plane. And another example is this, where obviously you may apprehend that in this case we have the punctured plane y not equal to 0. So for this case we have R2 divided of this x-axis, because on all these x-axis points we have y equal to 0, as well as we must ensure that the product of xy must be positive. That means whenever we have y negative, we cannot have x negative. So this plane is not considered. And similarly, whenever y is positive, we cannot take x negative. So all this side is cutted out from R2. Isn't it so? Because here xy is negative and here also xy is negative. No, sorry, not this one, this one, this one. So these two crosswise planes are punctured and these two are ticked, and this line is also discarded. So that is why we may define this domain of definition of this function. And for this particular function, we don't have any particular region which we should delete from the R3 plane. Isn't it so? Here we don't have any imposition on the values of x, y and z. Isn't it so? So these are the types of function we may discuss about the domain of definition. And another word which you find in your old textbooks, that this is a typical example of a rectangular neighborhood in a two-dimensional R2 region, where x and y both are varying as independent variables. Isn't it so? Whenever we have y and y prime, x and y both varying as independent variable, we may find the two limits as a and b, and the two limits of y as c and d. This is obviously the value of a and value of b, rather. These are limits of x, and then we choose the limits of y, which is c and d. So we have this type of rectangular neighborhood. Isn't it so? This is c and this is d, and so we have this type of. So this is termed as rectangular neighborhood, and if we choose say square neighborhood, then it becomes the same limit. Isn't it so? Similarly, we may define circular neighborhood. This is a circular neighborhood centered at origin having radius 1, we may define this type of circular neighborhood having center at A and B and radius R, and obviously you can see that this is an open neighborhood and this is a closed neighborhood. These are simple concepts which can be extended from your idea of a function of single variable. Okay, so these are the a few basic points about the domain of definition and the so-called rectangular, circular or elliptic neighborhood. We may have defined an elliptic neighborhood also at origin. Isn't it so? This is an elliptic neighborhood. So I am not going into very much details. You may find it in any one of the textbooks. We will try to elaborate on what may be defined as the limit of a function. When you define the limit of a function of two variables, x and y, both are assumed to be independent, then we define two types of limits. The locus point xy tends to a fixed point AB, P tends to a fixed point A, and this is termed as simultaneous limit. While if we take the limit of x tends to A and limit of y tends to B in a phased manner, that means we take the limit of y tends to B of fxy first, and then the resulting function, which is obviously a function of x, is taken the limit as x tends to A, then it is called iterated limit. It's quite conceivable. We are iterating. First we are taking the limit of y and then we are taking the limit of x, and that should be equal to limit y tends to b and limit x tends to a fxy. So they must be equal. This is also quite conceivable, because whether we take the limit of y first or we take the limit of x tending to a first of fxy and get the function of y alone and then take the limit as y tends to b, we must have the result same as this as well as this. And whenever these three limits exist, then only we can say that limit fxy as p tends to a has a definite value capital L of the limit exists, and the definition of sequence and epsilon delta goes hand in hand. So in case of double variable x and y both acting as independent variable, we must have all these three limits defined as simultaneous limit and iterated limit of different orders must be equal for the existence of the limit of the function. And whenever this limit exists, we may obviously write that for all delta neighborhood of A, rather for all P in delta neighborhood of capital A, we must have fxy lying within epsilon neighborhood of capital L. Isn't it so? These go hand in hand as the definition, epsilon delta definition of y equal to fx, a function of single variable. This goes hand in hand, and we all know that for continuity of fxy at A, we must have this equal to f at A, or we may write it as f a b. Let me write it clearly. Whenever fxy is continuous, at AB, a particular point, we must have limit of fxy as xy tends to ab equal to f of ab. That means the limit of the function is equal to the value of the function at that particular point with the definition of limit earlier defined.